Welcome. The following video gives you a quick overview of how the protection features of the PISA-B electronic circuit breakers work. Before we start operating, please note the following warning instructions. Read the installation manual for detailed warnings. When setting up the PISA-B, minimum installation clearances of 40 mm on top, 30 mm on the bottom, and 5 mm on the left and right side are needed. In case the adjacent device is a heat source, you need 15 mm lateral clearances. Between multiple PISA-B modules, no clearance is needed. Ensure that the main supply is switched off before working. Also, please take note of the following installation hints. Pay attention to ambient conditions and installation clearances. Mount the device on a DIN rail according to EN 60715 with the input terminals facing upwards. Please use suitable cables. The minimum and maximum diameters can be found in the installation manual or in the datasheet. Check that all 4 rules are properly inserted into the terminal connections. First, we will see how it reacts in measurement mode. Then we will check out what happens in parameter mode. We're now exploring what happens when a channel's load increases and eventually becomes too high, causing the channel to trip and start single flashing red. We'll begin by looking at this in measurement mode. In this mode, we use the percentage scale displayed on the left side of the LED matrix. You'll know you're in this mode by the triangular LED indicator located just below the matrix. First, let's review the set current. So channel 1 is set to 8 amps, channel 2 is set to 6 amps, and channel 3 is set to 4 amps, and we see we're using the slow tripping characteristic. At this point, channel 1 is at 100%, channel 2 is at 60%, and channel 3 is at 40%. Now let's see how the system responds when the load on these channels increases and how it handles an overload situation. Firstly, the load on channel 1 starts to increase. First, it increases to 120% and the yellow LED lights up. Then the load increases further and reaches 140% and the LED starts to flash red, indicating an overload. The system monitors this closely. If the load remains above 100% for a certain time, say a few milliseconds, the system automatically shuts down the channel to prevent damage, and thus the protection mechanism kicks in. Here is an example. In a factory, channel 1 powers a conveyor belt that's running at full capacity, using 100% of its available power to smoothly move products along the line. Suddenly, production increases, and more products are added to the belt, causing the load on channel 1 to go over 100%. This could happen because of the extra product load or an additional motor being used. The system monitors this change closely. If the load stays above 100% for too long, the system automatically shuts off channel 1 to protect the equipment from any damage. Now let's look at what happens on channel 2, which powers another conveyor belt. This belt also starts operating at full capacity, and the load on it begins to rise just like for channel 1. In this case, the load briefly exceeds 100%, but then quickly drops back to a safe level before the system's protection kicks in. One reason for this could be that a temporary spike in load, like a few extra products, was quickly cleared from the conveyor belt, allowing the system to recover before the overload trigger is shut down. Because the load falls back under 100% fast enough, the system keeps channel 2 active, allowing the conveyor belt to continue running without any interruption. Production continues as normal, with the system protecting the equipment while avoiding unnecessary shutdowns. So in conclusion, for channel 1, the system shut down the channel to prevent damage, but for channel 2, the system detected that the overload was brief, so it allowed the channel to keep running without disruption. This shows how the system reacts differently based on the severity and duration of the overload, ensuring protection while minimizing downtime. Now let's take a look at the parameter mode, where we want to see our set current amps on the LED matrix constantly. The first step is to switch from measurement mode to parameter mode. Once we do that, we can see the set values for the tripping currents for each channel, but it won't show how much load is currently on them. Just like in measurement mode, if a channel gets overloaded, for example, channel 1, the LED will single flash red to signal a total overload of that channel. The same goes for channels 2 and 3. You can reset the channel by pressing the related button a bit longer. This reactivates the channel, and it will light up green. The same procedure also applies in measurement mode. Please note, however, that the channel only remains activated for a short time and trips again if the channel is still overloaded. So finally, let me introduce you to the fail-safe mechanism. For this, we have a PISA-B with a short-circuited MOSFET on channel 8. This means that in the event of a short circuit in the circuit behind channel 8, the PISA-B can no longer shut down the channel. Other companies use a fuse as a fail-safe element. However, PULS uses an electronic fail-safe element in all PISA devices. What are the advantages of this? Let's watch the video. First, we check the actual current settings. Channel 8 is now loaded with 1A, and the LED bar goes to 100%. Now we increase the current to 2A. The channel must now shut down. The PISA-B shuts down the short-circuited MOSFET and notices that the current is still flowing. Then the fail-safe element shuts down directly, and all channels are deactivated for safety reasons. Also, the error E3 appears on the LED matrix. When we turn the device off and on again, the PISA-B remembers the last state of the channels, and as you can see, all channels are switched off and the PISA-B immediately switches off again, and error E3 appears. If you see error E3 on the device, just get in touch with our application engineers for assistance. You'll find the contact info on our website or in the video description below. And that's it, a short overview of the protection features of PISA-B. Thanks for watching. For more, check out our PULS channel or our website.